Gracias, Chema. Si tenéis algún...
Thank you, Chima. If there are any questions, you can ask us at the end of the interventions. And now we are going to have Ricardo Rueda, who is going to speak about gvSIG roads, management of conversation and auditing of roads using open source. He works in topography. He's got a lot of experience in the SIG world, in GSIS world. He's worked for different administrations. I can guarantee that because he's been working with us for the past 15 years. In the last few years, he specialized in management of road conservation, and he is responsible for the functionality of gvSIG roads. So if you'd like to start, Ricardo.
Vale, disculpar, a ver si podemos arrancar. Bien.
Okay, merci. Oh, thank you. My name is Ricardo Rueda. I'm the functional head of gvSIG Roads project. I would like to say that this is an open solution, interoperable, open source, open formats based on standards. So we have technological independence. Of course, I couldn't present here in this audience any other project. Our intention was to cluster all the information regarding the conservation of roads in order to be used by the different stakeholders and the citizens and the authorities. This is based on the road network. We have all the information from all the departments here. So we are going to make a state of the project. So this is, first of all, we have to see the status, the conditions of conservation, and we wanted to do an app for the management of the road conservation. And we also wanted to include work orders, and of course, we needed measurements and certifications, utilities. At this moment, this stage is completely finished and it's in use. A second part is introducing all this information in a Geoportal. The Geoportal, as we have seen in gvNIX, is integrated within the platform, and this is providing us with a very important utility because we do not have to change from users or from platforms. So the idea is to manage to edit the road incidences, all the information that we need to work on the roads conservation. This is finished now. It's being used and is ready to input all the inventory items which are still missing for the best operation of this software. The second stage was to be able to work in the field and collect the information, and that this is stored in our server. We should work in an offline mode because in the roads in many places we do not have coverage, and then we wanted to take the information, and after then we can transfer it to our computer, and of course we wanted to offer new functionalities, new utilities. And stage 4 is the phase in which we are now. We are about to finish this, which is the update of all this mapping in order to be able to manage if our roads change, then we wanted to be able to change the data stored in our system. In this way, we'll be able to manage the roads in the transport network in Spain. This tool, together with the dynamic segmentation tools, provide us with a very important power to this platform. And at the end of the year or beginning next year, this stage is going to be finished and in use. We are going to present what we have been doing. How is this app? With all the new components and the geo components in order to see how it works. Those of you who have been following the Geo's road trajectory, you will see that now we have added the GIS that facilitates our decision-making process. We have the geo component, which is vigilance agenda, and economic items. Then, which is the process? We have surveillance. We have different surveillance reports. We can generate a series of incidences. Now we can do a search of these, both filters and search in order to be able to locate them more easily. What happens if through this itinerary or the incidences we find an event which can generate incidences, and this is an agenda, so then all the problems that we find in our roads can be input here. Depending on the colors, we have a different status, which is pending of solution, out of deadline, and those who are responsible know which is the work that they have to do and which are the work orders. Also based on the incidences, we can generate work orders. So then we generate work orders and we can send that to the contractor and that solves the incidents in the best possible way. And in the same way as we do with all the itineraries, we can filter using any of the elements of the incidents. What happens with the geographical component if we see those incidences in the mapping? We have the same agenda as we used to have before, classified in colors, but now this is integrated into the mapping, and that facilitates our work and the planning of the conservation works in the roads. On the roads, and we can have access to different elements, rapid access, for instance, generating work orders or straight view connection. Here we have the example of the work orders list. We have a search utility, and we can create, we can display mapping, we can generate work orders, work reports, the cost of the operation, which is important. It's very important to know which is the cost of each operation. Here we can view the same work orders in cartography, also coded in colors. in such a way that we can see which is the situation, and we see that we can also have access to all the tools, including the cost of the operation. An example of a work order in which we have the option of signature, pictures, and all data of roads and all the information that we need in order to solve this work order. Adding to this, we have the option of generating a work report in which we can calculate the costs generated by this work order based on measurements. We can do that only for one order, or take that to the measurements section. And here we have a smaller Archimedes, which is a kind of budget software. And we can assess the cost of the works and generate the certifications for the contractor. What can we do additionally in measurements? We have the evolution of expenses, mostly investment by types of work or groups of works, and we can also have a margin. Now, if we go to the graphs, and the graphic part of the geo component, what we have here is a Geoportal where we have integrated the functionalities in a dynamic way. That means based on what we have selected in investments, we will have this view, this general view, this overview, and we have other tools. We have editions, areas, and we have a road search engine that can search populations or roads and translate in coordinates so that we can be located where we want to be. How can we do that? We do that thanks to the data model of segmentation of data. This model has been improved and is more adapted to the reality than the traditional dynamic segmentation software. Why do we say that this is enhanced? This is adding the coordinates. We have seen what this means, which is the distance to the origin. And why is it enhanced? Because our distance to the origin is not going to be to the origin of the road, but to the origin of the previous PK, because that's how we work. Then we can be located in the precise place without taking into account which is the PK for that road, which is usually 1,000 meters, but not always. Then we also have stored the geometry and all those elements that we want to position in real time, and they are painted based on this dynamic segmentation. Then we solve a historical problem of PKs having more than 1,000 meters. We can calculate distances from the previous PK, that the geometry is designed on demand, and that we avoid the duplicity of geometries and having to store many different layers and use more space to store information. As the Geoportal is integrated now, we need tools in order to work on it. This is the inventory management. How is this working? It is working in the same way as an inventory tool. Here we have all the incidences. It works in the same way as the incidence software. We can classify them and we can solve any problems. We have incomplete status. We have pending on update events. You have 5 minutes left. Here we have an example of an inventory search where we can see that we can search the signal, we can make filters. If you see here, the whole signaling and the inventory effects have an external border with the color of the listing of the signal of the inventory, which would be the workflow to update all this information. The premises are inventory taken, inventory updated. If every 4 years we have to do a data campaign, a data capture campaign, we are wasting money. So we assess through the inventory agenda, and we can interact with mobile devices and GPS. We are going to see a small video about the workflow so that you can see how this information is updated.
Vale, nos posicionaríamos en...
So we would be on a road. Here we are going to create a new inventory model, and we would only introduce the data that we need for that segment. We can even select through the image, even if we do not know the code, manufacturing date, etc. And we would create our element, our item here. If this item is affected by an incidence, which is in green because it has no problems, we can see that both in the listing and in the mapping, and we can generate an incidence directly from the mapping. As far as we have all data introduced, and then we should only save. So with only 3 clicks, we were able to introduce an incidence and generate the necessary information. We would save the item. And here we have generated our incidence, which is in yellow, because it's pending until we create the work order. We would create the work order. We would generate the instructions. We would select for that work order that inventory element, because we could have more and other work orders. And you see, as we have our incidents in green, the symbol of the signal has a change, and now it's in red in a state of incidence. We will close the work order. We will finish that, and here we have inventory affected, and what should we do? We are going to change the data. It changes to yellow because, despite that the incidence is finished, there are changes that have not been done. For instance, the plate, the signal plate. We modify those data. And then we see that it's in green again. I'm going to close. In this way, we have updated the information, and we do not need any data acquisition. I'm going to make it short because we do not have much time left. And from here, we can generate the same elements that we can generate in web. I had prepared a direct test so that you can see it, but I think we are going to skip it because we would need some time to do that, but we can generate all the information. We can synchronize the information in the server. And finally, it would be the update of the category of the mapping, the creation of road axis, addition and update of sections, historical management and tools for the validation of the mapping. I'm going to show the video. Here we have a road which doesn't exist at present. We have a sieve mapping with these road axes. We create this from the plugin of the gvSIG with the name, the code of the road, and then we have the number of layers in order to generate that we need in order to generate that information. What we are going to do is to send that to here we have an importer of information that transfer the origin data to the destination data. And here we can change all the data of the transport road. Once this layer has been generated, we will do the same thing with PKs. I'm going to go fast because it's done in exactly the same way. We would generate data, and we would create the data. And then we load that information, those layers, in our SIG. We would upload that on the server, and it makes the topological analysis. It says no problem. And once it's accepted, then we have it included in our platform. We update the screen, and that's all. And we have that so that we can select and create incidences, inventory, and any other things we may need. And which are the following kilometers? Many things we have seen in this meeting used to be here. They are not here anymore. And the list is shrinking. And when we are finished with everything, we will ask for more ideas. Thank you very much for your attention.